377. 377. Okay, so 4, 6 is nonlinear models.
Best hair, best smile.
4, 6.
I put Dakota down for best hair. Gotcha.
Okay, nonlinear models. That's what we're going to talk about today. Classifying scatter plots that are nonlinear models. So we're going to put data in to our graphing calculator. Then we have to decide if it's exponential, if it's power, if it's linear, what's going on with that function, and be able to create an equation off of it. So we're actually going to start on, let's see here. If you have a function that looks like this, if I have data that's kind of going like this, okay, that's going to be exponential. If I have data that's going like this, okay, yeah, it has to do with that as well, yes. This is growth, yes. This is going to be a logarithmic function. And then the third type we're going to look at is simply if it's something like this, it's linear. So we're going to have to use our graphing calculators to input data, and then from the data, we're going to decide what type of model it looks like. How do I insert data? What do I have to do first in my graphing calculator? Stat. And then clear list, and I have to do second, 1, comma, second, 2. So let's start by clearing that list in our data. And then after I do that, the second step is to go back into stat, edit. Then you're going to insert your data. Okay, I want us to insert the data on page 378. Okay, I want us to insert the data of that. So it gives us a bunch of like 2, 1, 2.5, 1.2, all of those data points. So I'm going to go 2, 2.5, 3, 3.5, 4, 4.5, 5.5, 6, 6.5, 7, 7.5, 8, 8.5, and then 9, and then 9.5. Okay, now here's the deal. On this chapter test that we're going to take over, chapter 4, you have to know how to use your graphing calculator. If you don't know how to use your graphing calculator, you're probably going to end up failing the test. 1.5, 1.8, 2, 2.4, 2.5, 3.1, 3.8, 4.5, 5, 6.5, 7.8, 9, and 10. Once you get all your data entered, remember you have to do second y equals, and you have to turn on your scatter plots 1 and 2.
Mine says air. We kind of like try to clear it.
And you're not doing that now. There's no way it will say error. You have to put a comma in between the L1 and
That'll
L2.
do it.
We're gonna charge one now.
Okay, so you have to turn on your stat plots, plot 1 and plot 2. I'm gonna turn these on. Okay.
Stop.
And then we have to set the window. Okay, so we have to set the window after that. So if I'm going to set the window, if you just set on this one the window to normal viewing window, it will work. If you do negative 10, 10, 1, negative 10, 10, 1.
We're doing the plot on number 370.
On 378, yeah. And then number 6, you have to decide what function the graph is. Okay, on this one, this graph to me looks like it's exponential because it looks like it's curving like this. So then you have to come over, lots of fun little steps, and I have to create an equation of it. So I'm going to go stat, calc, and then I'm going to go exponential on this one. Because when you graph it, it clearly is an exponential function. So stat, calculate, and then I'm going to go down to exponential regression, press enter, and enter again, and then create your equation. And I got that y equals a times b to the x, where y equals 0.51 times 1.4, okay? And then the regression is 0.99. But I don't have to have that in this formula because there's no r in this formula. So that's the formula for what we think is going to be this line. Then we have to go back into y equals and place the formula there. And graph it. So I'm going to go back into y equals. Now I'm going to put this formula of 0.51 times 1.4 to the x power. I'm going to press graph. And it should create a line that goes through my scatter plot. Yes, it does. Beautiful. So my scatter plot looked like a bunch of boxes like this. And then after I put that exponential regression in, it went like this. So I know I have the right set of data. If I had done a logarithmic regression, okay, if I had done logarithmic on accident, I would know that I did it wrong because my logarithmic function graph would look something like this. And that doesn't line up with what's happening, so I've chosen the wrong feature. That's what you're doing on tonight's homework.
How do you know what's happening?
You have to look at what you get from your original scatter plot. And if it's shaped like this, it's most likely exponential. If it's curved down like this, it's more likely logarithmic. And then if it's straight, it's linear. And then you go back into your stat, calculate, and you choose one of those three equations for it to create the equation for you. Okay?
But,
Yeah.
then the second one looks exponential to me too. Like, how would you know that that's not?
What do you mean this?
Like
This?
Yeah.
Because it's not going through, it's got to, basically, in order for it to fit, this first one's exponential, this is logarithmic. For it to fit, it has to go through basically as many points as possible.
Okay.
So if it like veers off of those points, now if it misses one or two, that's not a big deal. But if it misses half of them, it's not the right equation. Does that make sense? Okay. That is all your homework is. They give you 5 examples in your book of plugging this data into your calculator and deciding what's happening. So that's exactly what you're doing tonight on your homework. So I'm just going to give you the homework. The first portion of the homework